I'm sure you've heard that eating organic is good because pesticides are bad for you, conventional farming is bad for the environment, and organic food supports your local farmers. That all sounds good to me, but have you ever heard that there are some pesticides that are bad for your great-grandkids? Probably not. How does that even make any sense? Unfortunately, while it might not make any sense, it's true. And that's what we'll be talking about in today's video. Alright, so I wanted to do something a little bit different today. This time I want to do more of a deeper dive on a particular topic instead of talking about something more broadly. In this case, we'll be talking about a pesticide herbicide called Atrazine. And the reason is because I came across this really awesome study that was done by professors from the University of Washington State about Atrazine. And it's a pretty controversial herbicide, and this study adds a lot of information to that whole discussion, and I really want to share it with you guys. To sum everything up, I will also provide some conclusions and recommendations. The scientists don't really provide much in that area, so I'll be talking about, ways to avoid it, what you can do about the problems that it causes, and all of that at the end. So with that out of the way, let's begin now. Atrazine, while it might sound obscure, is used in no less than 75% of all corn crops grown in America. And it's in fact the second most commonly used pesticide or herbicide. I'm going to confuse that word dozens of times in this video, just ignore that. It's the second most commonly used herbicide in the entire United States. It's a potent endocrine disruptor, meaning it messes with your hormones, and about 70 million pounds of it are used every year. It's also very controversial. The EPA has stated multiple times that it's safe, despite it being completely banned in the European Union as of 2004. Clearly, there's a bit of controversy surrounding this whole thing, so that's why it's important to look into it further. And just for a bit of context, a lot of the time when they do toxicology studies on various pesticides and herbicides, they're only looking at amounts that are smaller than the EPA recommended safe limit. The problem with that is, in real life, a lot of times, the actual amount of a chemical present in the environment is way, way higher than the safe limit as mandated by the EPA. For example, with atrazine in particular, the safe limit I think is 3 parts per billion. It's been found at levels of around 4 parts per million in drinking water in the Midwest. Just take a step back, 4 parts per million is 1,000 times more concentrated than the safe limit of 3 parts per billion. So in most studies, they take that safe limit, they administer it to various test animals, and see what kind of response they get. What's unique about this study, though, is that they didn't look at the test animals themselves to see what kind of negative response there was. They actually looked at those animals' descendants. So the design of the study went like this. Take 2 groups of genetically equivalent rats, expose one of them to atrazine, but not enough to actually cause an immediate negative response in those animals, and allow the rats, separated of course, to continue to breed for multiple generations without continued exposure to atrazine. Then compare each generation of rats between the normal family and the atrazine family, if you will, and see if there were any differences in the health outcomes between those 2 groups. So it's a pretty clever design for an experiment, and let's play scientist for a minute and think about what would you expect to happen. At the very least, for the parents, maybe you'd observe some disease later on in life due to the minimal exposure to atrazine. Then, for the children, you'd think that since the parents were exposed to it, maybe that caused some problems reproductively, or the kids were exposed to it while the parents were pregnant, so that you would expect to find some other types of disease with the children. After that, though, maybe if you were really clever and paid attention in reproductive biology class, you would observe that since the egg cells of females develop while their mothers are still pregnant with them, that the grandkids might be affected. But after that, that's pretty much it. There's no other physical pathway by which atrazine could have gotten its way into the system of the great-grandkids or further generations. So you'd probably expect to see normal great-grandchildren. I think that's a pretty reasonable set of hypotheses, so now let's take a look at what actually happened. The researchers looked at a number of disease symptoms to assess the damage in each generation, and what they found is absolutely shocking. Not only did disease symptoms persist until the great-grandkids generation, some disease symptoms also increased in prevalence as they went down the generations. In fact, the only generation with statistically significantly more disease than the control group was the great-grandkids, which, according to our hypothesis before, was the one generation that we would not expect to have any symptoms. I'm going to run down the differences in the symptoms now. So in the atrazine children, they had a lower birth rate than the normal children. And since the normal children were of normal weight, a lower birth rate in this case is a bad thing. It signifies underdevelopment, malnutrition, etc. In the atrazine grandkids, they found in both males and females early onset puberty and genital malformations and disease in the males. Lastly, in the atrazine great-grandkids, they found genital underdevelopment in the males and early onset puberty in the females. Apparently, early onset female puberty is a problem among humans as well, and that was one of the most significant effects that the female rats had. The atrazine great-grandkids were also significantly underweight. But the weird thing about that is that they ate the same amount of food as the normal great-grandkids. So this would signify a decreased ability to process nutrients and turn it into body tissue than the normal great-grandkids had. They also observed behavioral differences among the great-grandkids, in particular, motor hyperactivity, which means they were hyper, ADHD-like symptoms. And with ADHD on the rise in people, I would say that's another interesting coincidence. And if you've been looking at the graphs, you'll notice that the effects actually accelerated down the generations, with no sign of slowing down. Unfortunately, these scientists didn't look at the great-great-grandkids, but I wonder if they had, what type of symptoms we'd have seen. Okay, so I know that's a bit crazy to think about. It doesn't even sound like this is possible. But given that that's what the main observations were, now time to put your scientist hat back on, and let's think about how to interpret them. First of all, how does this even make sense? The great-grandkids never touched a molecule of atrazine. The only logical conclusion is that they were affected through DNA. And that's exactly what the researchers thought as well. In order to test this assumption, they looked at the sperm cells of the males to see if there were any anomalies. The details of this get kind of complicated, and I don't think they're super important to discuss here. But essentially what they found is that in the sperm cells of the atrazine males, there were identifiable mutations in the DNA that persisted through the reproductive cycle. And this is, obviously very unusual. They call these in the paper epimutations, which refers to the fact that they're mutations on the epigenome, which is like heritable characteristics that are on top of the normal DNA. This is kind of ridiculous. Essentially the conclusion of this legitimate, well-done study is that atrazine permanently messed with the DNA of not only the animals that were contaminated by it, but of all their descendants in a number of ways that promoted significant and noticeable disease symptoms. From there, the implications of this go all over the place. For one thing, we now know that pesticides can cause permanent genetic alteration, which could affect your descendants forever. Secondly, the parents of the atrazine family were given such little atrazine initially that they didn't themselves show any symptoms. There could be hundreds of chemicals approved over the past few decades by the EPA because the test subjects showed no symptoms, yet their children might still be affected. Thirdly, if it's in your DNA, that means it can't be detoxed. A lot of environmental pollutants can be, but in this case, no amount of infrared saunas and activated charcoal and juice fasting will ever be able to detox your DNA itself. And the last one I want to mention, and perhaps one of the most crazy, is that there's a conspicuous link between the symptoms observed in the later generations of the atrazine rats and symptoms that have been on the rise in the US population for the past few decades, such as early onset puberty, ADHD, hyperactivity, etc. But I'll venture to say that our current and continuing health problems as a society might be caused by the fact that we are, in fact, the atrazine great-grandkids. After all, this pesticide and a lot of others started to be widely proliferated in the 1950s and 60s, which is about 3 generations ago for most Americans. And the other conclusion I'll make is that until a new chemical is proven to be safe amongst multiple generations after the first exposure, we have zero reason to believe that it is in fact safe. So that's it for the main details of the study. Now I want to start talking about what you might do with this knowledge. First, don't eat foods that were grown using atrazine. Avoid it like the plague. I'll show a little map on screen about the foods that atrazine is commonly grown with. The chief thing among these, as you'll see, is corn, but also soy, rice, wheat, and other so-called cash crops are commonly sprayed with atrazine as well. So you would do best to avoid those foods themselves, or foods that are made with ingredients coming from those foods. It just so happens that most of the foods that contain atrazine are unhealthy even if they didn't contain atrazine, so it's a pretty helpful coincidence that if you avoid those, you'll be avoiding a lot of unhealthy foods anyway. Another thing to look at is geography. If you live in an area where it's commonly used, you probably have it in your water. So if you live in such an area, or if you live in any area, you would do best to filter your water with a legitimate real-life filter and not a Brita or one of those crappy filters that don't actually do anything. That would be the next most important thing you can do. Other than that, though, aside from moving to Europe, where it's been illegal for over 15 years, unfortunately, there's not much else to do. It's possible that in the future, with more research, someone might be able to figure out how to reverse the epigenetic damage. But for now, the best way to protect your great-grandkids would be to eat organic, filter your water, and avoid atrazine at all costs. Alright, so that's all I have to say about this for now. This was definitely a long one, so thanks for sticking through till the end. If you liked this format, where I go in-depth on a specific study, let me know in the comments. I also plan to get more serious about uploading regularly, so if you liked this one, subscribe and check out my other videos, and I'll see you in the next one. Thanks for watching.